Good morning, everyone. I'm Kate Rubingh. I'm based here at Laurentian University, and I'm the Research Associate for the Larder Lake Transect scale work that we're doing. Today, I'm just going to go through some of the highlights of some of the new work we have. Okay, so I'd just like to take a moment to acknowledge our industry partners, which obviously we rely on for in-kind support. So this presentation today is in two parts. After introducing the geology of the Larder Lake area, we will discuss the implications on gold deposits using the new geophysical data for the area. And secondly, we will discuss the highlights from the new geochronology in the Hearst Sedimentary Basin. This geological map here of the Larder Lake area, you can see that the transect is shown in red. So we have the four main volcanic assemblages that we observe along the transect. We can see those here in green, shown here on the stratigraphic column. So those assemblages go from the Picaud through to the Blake River. And then we also observe the porcupine-aged sedimentary rocks and the Temiskaming. I just want to highlight that not observed stratigraphy is the Kidd Monroe and the Deloro that were not previously recognized. So we'll now examine the sequence of volcanic rocks from oldest to youngest. In the southern portion of the map area, we have volcanic assemblages. Here we can see the Round Lake batholith, and we have the Picaud at 2750. So this defines, we have a north-younging, north-dipping volcanic sequence from the Picaud through the Staunton Rockmire. I'm just going to put on my laser pointer, sorry. Through the Staunton Rockmire, through to these Blake River aged or skied volcanic rocks, which are here out of sequence. Moving on to, sorry, just bear with me. I can't move the slides, sorry. Yeah, moving on to the central part of the map area. You can see here, this defines the Larder Lake group volcanic rocks. These volcanic rocks are defined part of the Hearst Sedimentary Basin. So we have the Lincoln-Nipissing Shear Zone to the south that juxtaposes the Larder Lake group volcanic rocks and the Blake River age volcanic rocks and porcupine age sediments. The Larder Lake Cadillac Deformation Zone here juxtaposes the Larder Lake group volcanic rocks and the Temiskaming aged sediments. Moving on to the northern part of the transect here, we can see that's primarily the Blake River group. It's a fixed succession of those Blake River age volcanics, and we have these two regional scale faults, the Messina and Malvern Lake fault that we'll discuss later. So I just want to point out these pink polygons throughout the map area. These are the Temiskaming age intrusions, which intrude all the assemblages. So next we're going to review this area defined by the yellow box here. So the Larder Lake Cadillac Deformation Zone is shown in red, located here at the contact with the Larder Lake group volcanic rocks, shown in dark green, and the Temiskaming age sedimentary rocks in beige. The yellow circles show the distribution of gold deposits along this segment of the Larder Lake Cadillac Deformation Zone. We have the Omega deposit here in the west, through to the largest deposit, which is the Kerr-Addison mine at 11 million ounces. So now we're going to move into the geophysics. So the following slides will look at the various geophysical techniques conducted along the Metalearth transect line. Here we can see some new data from Rajesh. This is the gravity inversion data, which was combined with the regional gravity data. I want to highlight the gravity lows here in green and blue. And these delineate the sedimentary basin and the main bounding faults that we can see here, these red dashed lines. The Lincoln-Nipissing Shear Zone, the northeast trending fault here, which bounds the Proterozoic Huronian sediments, and the Larder Lake Cadillac Deformation Zone to the north. So note the strong, if we bring in the geology map, you can see these sedimentary basins. This here marks the unconformity between the Blake River Group volcanics and the sediments. And I just want to point out the gravity high, which we can see through this map here, and that strong gravity high defines the Blake River Group. So moving on to looking at the aeromagnetic data here, we can see that the Temiskaming and the Porcupine sedimentary rocks are these mag lows in blue, blues and greens. Once we overlay the geology, we can see the magnetic lows define the sedimentary rocks here. These are the sediments, both north and south of the Larder Lake Cadillac Fault. And the mag highs in pink and red, these delineate these Temiskaming aged intrusions with the McElroy stock and other intrusions which stitch the Lincoln-Nipissing shear zone. We also have mag highs, we have the ultramafic rocks defining the prototypes defining the Lincoln-Nipissing shear zone. We have iron formations that wrap around the Round Lake Batholith here in the Bacoud assemblage, and also we have a series of these northwest trending dikes. So next we're going to review this area shown by the yellow box. So here we can see once again the aeromagnetic map with the location of the Larder Lake Cadillac Deformation Zone shown by the black dashed lines. And we have, just want to highlight, you probably saw it on the previous slide, these northeast trending faults shown by the white dashed lines. And once again, note the location of the gold deposits shown in yellow there. So it highlights clearly the intersection of the Larder Lake Cadillac Deformation Zone and these northeast faults, which localize the gold deposits along the main structure. Note that the largest northeast structure defines that of the edge here of the Huronian Proterozoic sedimentary rocks. This is represented by the largest yellow circle, which is the Kerr-Addison mine. So this is some of the work by Metalearth. So this is a section that you're familiar with, the magnetotelluric and seismic data, this courtesy of Eric and Mustafa for this image. So when we're comparing the geology, the seismic and the MT, basically it highlights the direct correlation of these, the regional Larder Lake Cadillac Fault and that strong zone of connectivity, and also the other structures in the area, right? So we have the Messina Malvern Lake faults within the Blake River Group. So these have an apparent connectivity anomaly. It's lesser, but it's still obviously there. All three main faults are expressed on the seismic section by this distinct termination of these packages of strong reflectivity, which correlate with these main with the main faults, both the Lincoln-Nipissing shear zone, the Larder Lake Cadillac Fault, and the Messina and Malvern faults. So just note the depth here of the Larder Lake Fault, which is to over 25 kilometers. Overall, the MT survey documents a distinct contrast here between the structural hanging wall of these fertile systems. So next, we're going to focus on the application of the MT, and we're going to examine the nature of this strong conductive anomaly, which is spatially associated with the Larder Lake Cadillac Deformation Zone. So this map here, so this is the area we previously looked at. So we can see the long section line, so A to A prime, represents the section line chose to best represent the geometry of the 3D anomaly. So the conductivity anomaly you can see here has a distinct linear geometry and a moderate plunge that's shown by the black arrow on the section. So that MT anomaly that we were just previously observing correlates with the intersection of these two faults. So the main structure, the Larder Lake Cadillac Fault, and these northeast trending faults. So these two black lines represent the steep geometry of the Larder Lake Cadillac Fault in this area, which dips steeply to the south, as we observed previously on the seismic section as well. And then we also have these northeast faults, which are steeply dipping to the southeast. So the intersection of which is approximately consistent with the trend and plunge of that MT anomaly. And also note that we have just 2 stereo-nets plotted here. So that's consistent for the plunge and trend of the stretch lineation in this domain of the fault, from the data that's south of the Larder Lake Cadillac Deformation Zone. So now we're going to move into part 2 of the talk. So in this section, we're going to primarily focus on our discussion around the Hearst Sedimentary Basin and obviously the architecture of that basin. So we're going to review the Lincoln-Nipissing Shear Zone and some of the new geochronology that we have. So the Hearst Sedimentary Basin, located here north of the Lincoln-Nipissing Shear Zone, contains the Hurst clastic sediments, approximately 2690 in age. You can see this is the Lincoln-Nipissing Shear Zone, shown by that red dashed line. Previously, that fault zone was interpreted to juxtapose these older Larder Lake root volcanics, shown in pale green, which were Tisdale in age, 2705, against the undated McElroy assemblage, which lies here in sage green to the south, which was previously grouped as part of the Blake River volcanics in age. So the Lincoln-Nipissing Shear Zone, as we mentioned earlier, is stitched by a series of small volume Temiskaming age stocks, which have associated gold mineralization. On this map, we can see a series of blue dots, and I just want to draw your attention to. So this represents the previous geochronology in the area on the volcanic rocks, the intrusive rocks, and the sediments. So one point to note is that previously there was only one age on the felsic volcaniclastic rocks in this entire area, and that was dated on, located in here by Corfu in 1989, and that defined the area as Tisdale in age, and obviously then and part of the Larder Lake group. So these images represent the rocks typical of the Hearst assemblage, which is comprised, as you can see here, by these beautiful laminated greywackies and siltstones, some mudstones, and locally here we can observe these arenites and interbedded conglomerates. So obviously in part these are similar to the Temiskaming sedimentary rocks that we observe along the Larder Lake Cadillac Deformation Zone. So here we had samples that were submitted for detrital zircon geochronology on the greywackies of the Hurst, and these define these sediments to be consistently 2685 to 2691 million years in age, and consistent with the porcupine age sediments, and similar to the previous work that was done in the area by air. So along the Lincoln-Nipissing Shear Zone, we have these intrusions. This is a nice photograph here from Sean. These are the focus, which is the focus of his master's project. We're not going to go into detail on that today, but these intrusions have been dated consistently as Temiskaming age. The photo shows the Webster intrusion here, so it's a quartz feldspar ferric intrusion dated at 2672. We can also see an array of quartz carbonate veins which host gold mineralization. We have cross-cutting relationships here at the Webster intrusion, which provide a maximum age on the earliest regional north-south shortening event at 2672. So a series of felsic volcanic and volcaniclastic rocks was submitted for TIMS, laser ablation geochronology, under the Metalearth program these last 2-3 years. So these photos show we have these reworked felsic volcaniclastic rocks of the McElroy assemblage, and then we also have these altered, flattened, wispy fragments interpreted as possible pumice in one of the units along the Lincoln-Nipissing Shear Zone. These rhyodacite rocks and rhyolites that lie within both the McElroy assemblage and the Skeed assemblage, the consistent geochemical signature, and the McElroy assemblage overall contains is a predominantly pillowed and massive basaltic rocks with some periddotites, a significant proportion of komatiitic rocks, and a lesser amount of these of felsic volcanic and volcaniclastic rocks. Sorry. So map here, these two maps here, so this shows the previous assemblage map for the Larder Lake area that we reviewed at the beginning of the presentation, with the historic ages shown by these blue dots on the sediments, the volcanic rocks, and the intrusions. On the right-hand side here, this is the new geochronology from 2019 to 2021, shown by these red, the red dots. You can see we've got considerable new ages on both the volcanics, the sediments, and the intrusions in this area here. So we did a series of transects along the Lincoln-Nipissing shear zone. So this just represents the sample distribution. So we have felsic volcanic and volcaniclastic rocks of the Larder Lake area. The McElroy and Skeed were analysed, both from TIMS and in situ work at Laurentian. So previously, I just want to draw your attention to the age here by Corfu that we had. So that defined this package as Tisdale age. So we've got several new ages on the volcanic and volcaniclastic rocks here, which are consistent. And these are, I want to point out that they're consistent with this previous age on the Boston, in the Boston township here, with a 2711.5 or 2712 age, which implies that this entire package is of a similar age. This was previously defined as the McElroy assemblage, and it was undated, and it lies along that package of rocks lies along the Lincoln-Nipissing shear zone, is now consistently Kidd-Munro in age. And we also have a felsic volcanic rock that was dated in what is defined as the Skeed assemblage. This also has a 2716 age, consistent with the Kidd-Munro. Okay, so just in summary, so our new mapping has implications on the nature of the Lincoln-Nipissing shear zone and our understanding of the Hearst Sedimentary Basin. So these ages for the Kidd-Munro range from 2712.7 to 2716.9, and these all lie within the upper Kidd-Munro and are consistent both north of the Lincoln-Nipissing shear zone here and south. So if we look at the Kidd-Munro here, so just highlighting that assemblage, we can see it here now in this bright green. So this new map therefore represents consistently North Younging, North Dipping volcanic sequence, starting with the Cowd through the Staunton Rockmire, the Kidd-Munro to the Tisdale, but then we still have the question of the Blake River aged, the Skeed volcanics here, which are out of sequence, and we don't have a handle on that. So just in the regional map here illustrates the Kidd-Munro assemblage in pale yellow. Sorry, I'm just, apologies. I think I've missed a part. Okay. So the regional map illustrates the regional extent of the Kidd-Munro assemblage in pale yellow, which is typically located north of the Porcupine-Desta Fault and associated with VMS mineralization in the Timmins Camp. So this is new for this area south of the Larder Lake Cadillac Deformation Zone, where you can see that we typically, there hasn't been Kidd-Munro ages documented. So I would just like to give special thanks to Eric Roots, Mustafa, Rajesh, Tom Hart at Transition Metals, Jeff, Mike Hamilton, and at the Jack Satterley Lab in Toronto.
Great, thank you very much, Kate. We have a message on the chat, or a question on the chat from David Hartwell. So along the Larder Lake Cadillac Deformation Zone, Agnico's Upper Beaver deposit's the most advanced. It's more copper rich. Any thoughts on this?
Yeah, I haven't done, I know we have a master's student starting on the Upper Beaver. Yeah, I'm not sure. I'm not, to be honest, Ross, I'm not familiar with with that.
It's
Yeah.
well north of the Cadillac Larder Lake. It's on subsidiary and it's associated with Temiskaming Intrusions.
Right.
The George Benoit at Laval has a joint insert grant on this, and so there'll be a lot more information forthcoming on that shortly. Any other questions for Kate?
Hello, Kate. This is Benoit again speaking.
Hi, Benoit.
I'm curious about the northeast trending fault that seems to locate the distribution of the gold deposits along the Larder Lake fault zone. At deposit scale or outcrop scale, what is the manifestation of these northeast trending structure and chronology versus domain foliation?
Yeah, it's a good question. Yeah, so when you're in the field, you know, the final expression of these structures is I think they're actually reactivated normal faults, so they're offsetting, they're cutting across some of the early folds in the area, and they're offsetting the nose of some of those structures. So they would be, like, in terms of timing, I would assume that they would have to be late D2, yeah, and then reactivated during D3, or they may actually be, yeah. So, but they're definitely post that earliest. I believe they're post the earliest north-south shortening event in the area.
But you mentioned that these are like normal faults?
Well, from the map pattern, you know, they displace, or they displace the stratigraphic units, right? So I think their final expression, you know, I think they've obviously been reactivated. They have a long-lived history. I think they obviously must be relatively early, and then, you know, the latest movement of them is possibly normal.
So they displaced the Larder Lake Cadillac fault.
Yeah, well, I suppose the folds that we see south of the Larder Lake Cadillac Deformation Zone within the Hurst assemblage there. So we have early, the first generation of folds. They cut across the hinge of those, and obviously we have two main regional fabrics in the area. The main fabric related to the north-south shortening and the Larder Lake Cadillac break, and then we have that northeast later fabric. So those faults are really parallel to that later fabric.
Okay, thank you. And about Upper Beaver is a totally different deposit. It's a synmagmatic deposit, and it shares analogies with the skarn and some alkaline copper gold deposits. So it's something that is a pre-main phase of deformation.
Okay, thank you.
We have time for one more question. No, okay. I'll just weigh in though. So these northeast trending faults, you know, they're really difficult to see in outcrop. I don't think
They are.
most of the time they're, you know, lakes occupy them. So Bear Lake is sitting within one, but their most obvious expression is to the east, where they're down dropping the Proterozoic sediment, and so they seem to have a control. You know, that was Jay Hodson's idea, you know, way back in the 80s. He had that outline, and I think he's right. But it's you know, what their earliest expression was, I don't know. But right now they're that as a normal fault, which is at least Proterozoic in age.
Yeah, but I imagine that's they're reactivated, right, Ross? I mean,
I think so. Yeah.
I can't, you know, I don't see their previous expression in the field. That's impossible to tell.
Yeah. Yeah. Okay. Thanks very much, Kate.
Okay. Thank you.